Hi, so second video on bridging the gap between GCSE and A-level, and we're going to concentrate on quadratics today. So quadratics you would have had at GCSE, and I'm sort of going to go through some different things that you would know already, and then maybe give some kind of a couple of new little things as well that you might that you'll come across in A-level. So you can just sort of see, because it's not so much of a bridge, so I'm going to try and teach you a little bit of something different, hopefully. Okay, so first of all, moving on to the first question. Now here is a question on factorising harder quadratics. Now it's really easy to just not bother with these at GCSE and just think, oh, they very rarely come up, won't worry about it. But at A-level and just generally, it's quite nice to have some practice on how to do factorising harder quadratics. And when I say harder ones, I basically mean when the coefficient of the x is bigger than 1. Okay, so you do need to understand what happens with it and how to work it better. There's loads and loads actually of different ways of doing this, and to be honest with you, I don't know what's easier. Different students find different methods easier, and some people use trial and error. Some people just kind of look at it and think they can just work it out from there, and other people use like grid methods, cross method. So what I'm going to do is show you just a method. I don't even know what it's called actually. I've just kind of picked up different methods here and there, but a method I quite like is when you kind of separate the x value out. I think it might be the squiggle method, but I'm not really sure. So it doesn't really matter what method you use, and you know just what works for you really. So the first one, I'm just going to go through this just as a bit of a reminder. So what we want to find, we're always going to be looking for a number, two numbers which multiply and times. So multiply to get something and add to get something else. So when it's harder quadratics, you have to first of all times the a and the c together, so the 2 and the 3 in this case together, to get what you need, the two numbers you need to find the multiplication. And then so that's a kind of a times c, if you think of this as a, b, c. And then to find the adding is the one in the middle, the 7. So I need to find two numbers which multiply to get 6 and add to get 7. That's my first step. And they're all positive, so which makes it slightly easier. So thinking about the multiplication of 6, you've got I don't know, 2 and 3. Okay, that doesn't work, it doesn't get 7. Thinking this, I was trying to get some other ones, but no, 6 and 1. You multiply them together to get 6, and you add, and they will give you 7. So it's fairly straightforward. So here are your first numbers, and in a normal factorising question, you would just use them in your brackets. But actually now we have to do something different because we've got this coefficient of 2, and it changes the rules a little bit. So what we do with these this time is we separate down this x value. So we end up with 2x squared, and our x value is now going to be split into 6x and 1x. So it's literally separating them out into those two, so to kind of just break the 7 down, because it's always going to be two numbers which add to get that 7x. Okay, now what we want to do is take the first two and the second two and factorise them separately. So again, we're going to take these as two separate things. So 2x squared plus 6x, if we take out 2x, we'll get x plus 3. So all I've done there is divided 2x squared by and 6x by 2x. You can see that 2 and x go into the both. And then on this one, x plus 3, you can only take out one of those, and it's just going to be x plus 3. But you can kind of see now that, and you will get this every time, and if you don't, then there's something that's gone a little bit wrong. The two brackets here are exactly the same. Okay, and that's really, really key, because that means that we can then go, well, I'm timesing this by that, and I'm also timesing this by that. So 2x by x plus 3 and 1 by x plus 3. So x plus 3 becomes one of our brackets, and the other one is just the other two parts. So 2x plus 1, because I'm timesing both of these by the x plus 3, and then that's it really. That's factorising. And if I was solving, if I wanted it to equal 0, so if I want to know what it was at 0, I would just do, well, x is equal to minus 3, or x is equal to negative 1 over 2. Okay, so what's the value of x to make this 0? Okay, so hopefully you followed that. I'm going to just do one more example. And again, it is again a GCSE, but you could easily get away at GCSE with not knowing this, and you know, it doesn't come up very often. So let's just look at the next one, factorising harder quadratics. We've got a 5 here and a minus 2. I'm going to show you another method now, just to mix it up a bit. Again, if you want to pause the video, have a go, use the method that we had before, or use your own method if you want to. Try not to use a calculator, because I know you can at A level, but it's really important you understand the skill and how to do it as well. So another method I use is very, very similar in a way, is I use this x. I separate it out with this x, and I think, well, I still do 5 times minus 2, and that gets us minus 10. And then I do, well, this is a times c again, very, very similar, and then the 9. So I just separate it a bit like that. And I still want two numbers which multiply to get minus 10 and add to get 9. So multiplying to get, obviously, minus, when you've got a minus, you have to make one has to be minus, one has to be positive. So minus 10, I can think, well, 10 and 9, they're only one away. It can kind of be quite obvious in that case. So it's going to be minus 10 plus 1, or you've got 10 and then minus 1. Now, which one will get you positive 9? Well, it'll be this one. It'll be this one here, won't it? So 10 and minus 1 gives you minus 10 if you times them, and also if you add them, you get 9. Okay, so there are your two numbers. I then put them in the sides, 10 and minus 1. And what you do now, which is really, really weird, and if you've not seen this before, you might think, what is this? You kind of put it all over the number that's a, basically. So in this case, it's 5, because a in this question is 5. And you kind of write it out like a fraction. And I want to simplify each fraction. So 10 over 5 becomes 2 over 1. You keep it as a fraction though, don't get rid of that 1. Minus 1 over 5, you can't do anything with that. And so we use, now look at these two, they look a bit like fractions, but we're going to use them to put in our brackets. And what we do, we use the denominator of this particular thing for our x value. So x plus 2, and this one, that's x here, and then whatever's on the top is your number. And this one will be 5 at the bottom, so it's going to be 5x minus 1. And you can kind of obviously have a check. 5x times x is 5x squared. 2 times 5x is 10x. Minus 1 times x is minus 1x. So that's, add them together, you will end up with plus 9x. And then 2 times minus 1 is minus 2. So you can kind of check it out. It's really easy to check once you've got it in. And obviously to get it to 0, x would have to equal minus 2, or x would have to equal positive 1 over 5. Okay, so that's just a little bit of a brush up on factorising harder quadratics. I'm now going to look at a couple of A-level questions. It's nothing to do with factorising. I'm going to kind of move on from that now and talk to you about the shape of quadratics and stuff like that. Okay, this is actually straight off an AS paper, this question, and you might recognise it's given you a quadratic there. So x squared plus 6x plus 11 can be written as x plus p squared plus q. Now this format here, you might remember this, called the completed square format, and so that's all it's telling you to do. You want to convert this to completed square, okay? And that you have to be really, really good at these. It tells you different bits about the quadratic, which we'll talk about later, but because we've got a question later on about this. But for now, let's just change this into the completed square. So to get this p value here, what we have to do is half the b value. So you end up with x plus 3 squared. Okay, so that's that bit. Then, because what happens when you square x plus 3 squared, you end up with, if I did this, I'll just do a little side working, you might already know this. But if you actually did write this out, you'll end up with your x squared plus 6x. So that is this part here, but you'd also end up with a plus 9, because 3 times 3 is 9. So you kind of end up with this 9 that you don't want. So you then minus the 9 away. So you minus the square of this number here. Okay, and then you've got this part, you've made it, so all this here now, up to here, is this bit, and then you just add the 11 after. So, excuse my scribbling a little bit, plus 11, and then you just rearrange it, so it's obviously collect minus 9 plus 11, you'll end up with plus 2. And that's it. So that would be, in this case, that would be your answer to that question. Okay, we're going to talk about what we use completed square, but in this question, it actually only asks you to do this anyway. Okay, you can see this is A. We're going to do question part B in a second. So let's go to the next question. In the space at the top of the page, 7, sketch the curve with the equation, and it's giving you that equation from the last slide. So showing clearly any intersection with coordinate axes. Okay, so I'm just going to rewrite here, because obviously this is the second part. You would already have x plus 3 squared plus 2 as your completed square in that format. So I'm just going to write that above there. Now obviously this page, top of page 7, is just because that was on the exam paper and I've just copied a question, but so you don't need to worry about that. But this sketching the graph is really important. So clearly showing any intersections. So we know that it's positive because it's x squared. It's not negative, so we know what shape it's going to have. It should have that U shape. We also know that it goes through the axis, the y-axis, sorry, at 11. This one here, because when it goes through the y-axis, sorry, the value of x is 0, and if you substitute in 0 in here, you end up with y is going to equal 11. So again, we should know that from our things. So we know it's going to go through there. We also know, now this is where completed square comes in, this tells us the minimum point. It gives you the coordinates. Now it is important though you understand that it's not where what we do with the coordinates. You need to reverse the one inside the bracket, so that the coordinates, the minimum value, and it's minimum when it's a positive quadratic, minimum value, so you reverse this plus 3 to make our x value as -3, and our y value will just be that 2. So our minimum value is going to be -3, so -3 and then 2. So it's going to be over here like that. Okay. Now, if you look at this here, if you think about this being a quadratic, you can kind of see that it's not going to go through the, it isn't actually going to go through the x-axis at all. Okay, even if you try to do this, you'll realise that you end up with a negative. Now what I can do, and I'll just show you this why, is that if you look at this here, the completed square format, squared plus 2, and if I equal it to 0, which means that the function is 0, so where the x values are, so obviously when y is 0, it's where it goes through the axis. Then if we rearrange this, we end up with x plus 3 all squared equals -2, and then we end up with x plus 3 minus 2 root. Now you can't have a square root of a minus number, because when you square any number, it's positive. So therefore, this makes it that if you put this in a calculator, it would not be defined. Therefore, it doesn't, basically just doesn't go through this line here. Okay, but when you actually sketch it out, you can see that so there's actually only 2 points that you can. It's just show any intersection with the coordinate axis. With the coordinate axis, the only intersection is actually there, and the minimum point you've already kind of found. Okay, so that's really understanding quadratics. We have got a C question as well, so let's just have a look at C on this one. Now, right, okay, now this C question is about the discriminant. Now the discriminant is going to be new unless you've looked at discriminant on something else, but it's not in the GCSE. Now, I just thought I'd quickly show you what it is before we did the C part of this question. So the discriminant is this part underneath the quadratic formula. So this is a quadratic formula. So you recognise this hopefully. Now this kind of brings you back to that bit a minute ago, because if this number here, if b squared minus 4ac, if it's less than 0, so if it's a negative number basically, then there are no values. So therefore you'll have a graph which does not go through the x-axis. Okay, if you have, so I'm just going to write this out again. Sorry, b squared. If this part of is underneath the square root, it's less than 0, there will be no intersections of x-axis. Okay, now if b squared minus 4ac equals 0, now if you think about what happens with this, if this equals 0 under here, under this here, what happens, you'll just end up with minus b plus or minus 0. So actually the plus or minus, whether it's a plus or a minus, you're going to take away 0. So you only end up with one root. So what that would look like, it would kind of go on and there like that. So for example, this one would be x, I don't know, minus 3 squared. It'd be 2 roots, but it would be the same. It'd be a repeated root. Okay, if this b squared minus 4ac equals 0. Okay, so it's really important. I mean, this is something you would definitely go over a few times and just get your head around it a little bit. Discriminant, it's really important. Okay, b squared minus 4ac. If this is greater than 0, which means if this is greater than 0, your plus or minus is going to come out with 2 answers. So there are 2 possible roots. So there's no roots. When we say roots, we're talking about how many times they go through the axis. You've either got no roots, where it's floating like that. This one, the first, so this is sort of A here. B would be 1 root. And I'll just draw a little sketch here of C. And that was just like when it's got 2 roots like that. Okay, so that's about the discriminant. And when it says that it sometimes gives you information. We'll look at some questions on this in a minute, but this is called a discriminant, and it all bases around the quadratic formula and what happens with that section under there. Okay, so it's a good idea to copy that down. Just have a think about it a little bit, understand what's going on, and play around with that a little bit. Okay, now here, this is why I wanted to show you the discriminant before the question. So find the value of the discriminant of x squared plus 6x plus 11. So if you remember the discriminant, it was b squared minus 4ac. And if you know the quadratic formula, it's just that part that goes under the root. So that is the formula. So all we need to do is plug our numbers in. So we've got b, which is 6. So 6 squared minus 4 times a, in this case it's 1, because a is the x squared value. And then c is the 11. So times 11. Okay, so you can kind of do it like that. So 6 squared is 36 4 times 1 times 11 is 44, minus 44. So 36 minus 44 is going to be 8, sorry, minus 8. So the value of the discriminant is minus 8. So therefore, as we've seen actually in this question anyway, there will be no real roots, because this is less than 8 is less than 0. Okay, so you can look at any quadratic, pop that in, pop b squared minus 4ac in, substituted in b, a and c, to figure out how many roots that particular quadratic has. Okay, so I hope that's kind of explained what the discriminant is. We're going to look at that again in a short while as well. Okay, so this next question is, it looks really complicated. It's got a k involved here, as well as the x. But if you break it down, this x squared here is your a value. This bit here is your b, and this bit here is your c. So your a, when you look at this, what it's actually asking you to do it in the form, and this is a completed square form. So you can see that you do exactly the same as you would do. It's just going to be all in terms of k. So the first thing to do, you'll end up with your x plus, and what you're going to do is half b, so half of 4k is going to be 2k squared. And then remember, you'll be minusing the square of 2k. The square of 2k is 4k squared. You not only square the 2, but you need to square the k as well. And then the c that you'd add on the end is going to be, you're just going to add on 3 plus 11k. You can't actually do anything else other than that, and that's as it goes. It's all in terms of k. So whereas this q here is constant in terms, this is all in terms of k, and so is p is in terms of k. Okay, so that's the first answer to that one. Okay, and then it's got give the equation fx equals, has no real, given that, so it's giving you some information, given that the equation, so this function has no real roots. Now remember what we said when it had no real roots, that meant b squared minus 4ac was less than 0. Okay, so that tells us something. We can use that information, that inequality, to help us figure out the values that it could be. Okay, now, so given that it is less than, has no real roots, let's now use this. So 4k is going to be our b value. So we would do 4k squared. Remember, you have to square both here because you're really doing, this is 4 times k, so you're squaring 4 and you're squaring the k as well. Okay, minus 4 times a, which is 1. Luckily it's just x squared, so it's just 1 in front of the x, isn't it? And then the c is 3 plus 11k times 3 plus 11k. I'm just going to put that in a little bracket. Okay, so let's I'll deal with that in a second. This bit here, so if you think about this as minus 4 times 1 is just minus 4, and we're going to times that by both 3 and by 11k. So you should end up with I'm just going to simplify that bit there, and then minus 4 times 3 is minus 12, and then minus 4 times 11k is minus 44k, and we know all of that is going to be less than 0. So we look at this here and just change it around so it's in a quadratic format. Is less than, oops, 0. If you think about it now, you've got a formula here. This just looks exactly like a normal quadratic, I suppose, apart from this k instead of x's, but that's fine. And how we deal with this, we think, well, it's less than 0. This is now an equation. So you can, first of all, you might spot that they're all divisible by 4. So you can reduce them down. So if you divide it all down by 4 k squared. It just makes it easier to look at, and it is possible to do that. It's a multiple. And then you've got 4k squared minus 11k minus 3. Now, what you need to now think about is it factorizable? Do I need to use the quadratic equation to figure out what the values are here? So let's have a look at it. So 4 times minus 3 is going to be minus 12. So if I'm using my cross values, minus 12, and my b value is minus 11, can I find two numbers which times to get minus 12, but add to get minus 11? Let's have a think about this. So minus 12, obviously you've got 4 times 3. One will be minus, one will be negative. You've also got 12 times 1, which is, because there's one apart, it's often that that's the case. So 12 times 1 is obviously 12, but if it's minus 12 times 1, that will add to get minus 11. Okay, so just put them all over there. And then I'm going to put them all over the 4, because that's what our a value is here. And then this gives us, this one here gives us one fraction. So I'm just going to draw it down here so it's a bit, so it'll be 4k plus 1 will be one of my brackets, and then this one, running out of space, sorry, I'll be reducing it down because obviously 12 goes into 4, so you can just do minus 3 over 1, and you end up with k. We've got k rather than x's, 3. Now what this does now give you, and it's less than 0, because it is it's actually a quadratic inequality. So now we have the 2 points where they cross. So they're going to cross at minus 1 over 4. So minus 1 over 4, minus a quarter basically. So minus a quarter. And it's also going to cross at positive 3. Okay, so it's going to look a bit like this. It's also going to go through, if we look at the equation at minus 3, think about it like that. So this is just thinking about this as a quadratic really, and a quadratic inequality. We will be looking at quadratic inequalities a bit later, but this is basically what that is as well. And then it's less than 0. So less than 0 means it's basically under this line. It's less than 0. So if it's less than 0, if it's under this line here, basically means that k has to be greater than minus a quarter, but less than 3, because it's basically between, if you look at the x values, between these two values here, because it's only this bit here we're interested in, this between these two numbers, this is where k is going to make this particular function less than 0, and therefore mean it has no real roots. It seems really complicated because you're saying, well, if it's got no real roots, why has it got roots here? But you're actually drawing the discriminant of it. You're not drawing the actual quadratic itself. So that's where it can get a bit confusing. So all I'm doing here is finding numbers which makes it so that this quadratic will not have any roots. Okay, and anywhere between minus quarter and 3, that will be possible. Okay, I hope that's made sense. Again, this is much higher than GCSE, and you probably wouldn't have anything like this at GCSE, but this is the kind of thing you will be expected to do at A level, and there will be obviously much more examples of this if you go and find things. This is quadratics, inequalities, but with also not only that, is you've got this k coming in here. They use k quite a lot, and that's because it gives you information for you to then find. Okay, so it's not, the more you do, the more it becomes a little bit easier. Okay, now it's got another question here. So here is exactly the same. This is actually part C. Given that k equals 1, sketch the graph, show the coordinates of any point at which graph crosses a coordinate. So our if we substitute, if it's got given k equals 1, all I'll do is substitute in k as a value of 1. So x squared plus 4 times 1 is 4, plus, and then 3 plus 11k, so 11k is going to be 11 times 1, 11, so that's going to be plus 14. Okay, so all I've done is substituted in k, very, very straightforward. Sketch the graph of y, showing the coordinate of any point at which the graph crosses a coordinate axis. And so we'll end up using, looking at this and thinking, can I factorise? Well, I know for a start it's going to go through my axis at 14. So I know that. I know it's going to be positive. Can I factorise it? Well, can I get 14 and then 4? I don't think you can actually. So think about it, 14. The only way to get 14 is going to be 2 and 7, obviously 1 and 14, neither of which gets you to 4. So no, it's not factorisable. So you have to think, well, okay, you can either use the quadratic formula, or I could use complete the square, and I'm going to use completing the square. So I halve my b squared. You're minusing 4, you're minusing the square of that b value, sorry, half a b value I should say, and then plus 14 x plus 2 squared minus 4 plus 14, you end up with plus 10. And then, so that gives me my, this here is completed square format, that gives me my coordinates of minus 2, 10 as my minimum point, so minus 2, 10. So that is going to be my, so again, very, very similar to the last one. That is not going to go through the axis at all. And if I can prove that if I wanted to carry this on here, x plus 2 squared plus 10 equals 0. What I would end up doing is having minus 10 over this side. We'll get used to these and see exactly, straight away you can kind of see it's not going to. And you square root, you can't square root a minus 10. So you know it shouldn't either, even after you've sketched it. So therefore it will not have any roots. And also you can kind of see with k is 1, that is in our remit. Do you know when we said if k is greater than minus a quarter and less than, was it less than 3? Less than 3. So it's within this, if k is anywhere between these, it's not going to have, it's going to be a negative. It's going to make that it's going to make that particular, this quadratic a negative, and therefore it's going to float above and have no, it's going to have no roots. So that's what we call roots, the ones that go through the x-axis. So hopefully that was, that's okay for you. I know it's difficult, and this, but this is kind of the crux of quadratics, if you like. This is how it kind of starts. If you're even slightly understanding it and you're really new to it, then that's great. And if you don't at all, then at least you know what to expect, and maybe to go and look for some questions very similar. Okay, so here is one more. I'm going to do one more question on this, and please put any comments in the comment box down below, because obviously it's quite nice for me to see how, if people are getting on with these questions, if they find them too hard, too easy, if I'm going too fast, too slow. You know, I'm very new to any of this. So, okay, given that the equation, and so this is a quadratic again, q is a constant and has no real roots. And again, when it has no real roots, it's going to be the b squared minus 4ac is less than 0. So quadratics, to be honest with you, if you know about discriminant and how it works, that's like the biggest thing. Okay, show that q squared plus 8q is less than 0. So again, we're just rearranging this then. It just wants us to rearrange it to this, and show that always means that you need to get to that point in logical kind of steps. Okay, so if I substitute in my q as my b, because as you can see, q is my b value. 8q, minus 4ac, so minus 4 times a, which is 2q. You're going to basically pick out the bits that aren't the x's, so like that and that. And my c is, I'm timesing it by minus 1. So therefore q squared minus 4 times 2q, so that's going to be 8q, and then I'm going to then times that by 1 as well. So you don't have to do it in lots of steps like this. And obviously timesing it by minus 1, you're just going to get, which is always going to be minus less than 0. You're always going to get this minus, timesing it by minus 1, that kind of just turns the plus into a minus into a plus, sorry. And there you go, and you've got the answer. And you know it's less than 0 because it tells you it has no real roots. So this minus 0 is actually a given really from that. And then it kind of confirms it by the show that anyway. So hopefully you can see that. There's too much. These marks over here, I have left them on there to see that you can see how many marks you would get for that. So therefore you need at least 2 steps. So the first step would be the one just substituting, and the next step would be actually then showing it gets to minus 1. It gets to this. Okay, and then it says hence find the set of possible values for q. So if you're finding the set of possible values, then you are going to be solving it. So q squared plus 8q is less than 0, and if you factorize this one out, you end up with this. So q, oh no, that's all actually, because it's only a small one. There's not really much going on here. So q is going to be, for this to be less than 0, it has to equal q is less than 0, or q is, hang on, I've lost my mind slightly on this. Okay, sorry, that's my bad. So if you write this out on here, if you've got a q which is outside here, so you've got the q on the outside and the q plus 8 on the inside, you know that here, if this is a normal one, it'd be minus 8. So this is minus 8 over here, and then this would actually be 0, because if q is 0, then this makes this 0 as well. So whatever's inside here, that'll make that 0. So if it's an outside, it gives you the 0 value. So therefore my graph looks a bit like that, minus 8 and 0, and then it's got to be less than 0. So again, it's the bit under here. So therefore q has to be, sorry, to give myself a bit more space, q has to be greater than minus 8 but less than 0, and then so because between this it will be under the line, and anything after 0 or before minus 8, it actually makes it positive, and then there will be roots. So sorry about that bit in the middle there, it got through me, but it does throw a lot of people. As soon as it doesn't look like a quadratic, it is a quadratic. It just means that this is, it's just add 0 or whatever. It's not a there's no number, that's why it's a 0. Okay, so you just bear that in mind. Okay, so hopefully it's given you a bit of an idea about the kind of questions, how they might be asked in a these are AS questions, so this is the easier side of quadratics, and they can get quite a bit harder. But if you've understood up to now, it's a really good bridging exercise to look at quadratics. Go on anything, that depends on what you've got access to, but I really like Maths Watch and Hegarty Maths. Look at some questions. They've even got some interactive points where you can just give yourself some, because this isn't this is still partially GCSE, because even though they're not going to ask you anything to do with discriminant, they will, it's like factorising the harder quadratics, understanding how to plot a quadratic, and all that sort of stuff is there, and it is in GCSE, so you can always just look at that. And then obviously if you've got access to A-level books, or if you want to go on physics and maths tutor.com, I think it is, it's absolutely full of resources, and you can look at old stuff because this stuff was in the A-level before it changed, so it's absolutely fine whether you're doing AQA or Edexcel. This stuff is or any other, then all of this will be really, really useful for you. Very, very important topic. Okay, but please ask any questions down below if you are struggling with any of this or need some more advice, want some more videos on this particular or any other topic you want me to talk about, I will be issuing different topics over the next couple of weeks. Okay, thanks for listening, and please subscribe